Jay, floor is yours.
First of all, thanks so much for coming to my talk. I will talk about vulnerabilities in SCADA applications. Mainly, I will show you how it is easy to discover vulnerabilities in SCADA applications. A little about me. I am a security researcher in SignalSec, and also I am organizer of NOPCON conference in Istanbul, Turkey. Mainly, I'm focused on vulnerability research, bug hunting, and reverse engineering area. Oops. Okay. So let me explain what is SCADA and how SCADA security started. Actually, SCADA systems are in our daily life for a long time, but we were not interested in SCADA security until last year. To be honest, I was not aware what is SCADA until last year. But after Stuxnet attack in 2010, we all learned about what is SCADA and what is SCADA security. So Stuxnet attacks and also Duqu attack was a milestone for SCADA security. You know, Stuxnet attacks targeted Iran nuclear plants in 2010. And after that, SCADA systems got attention in both security industry and for hackers. I'm sure about that all of us know about Stuxnet attacks, so I will not mention it again and again. So I will just pass about it and start to explain what is SCADA and show some example vulnerabilities, if computer lets me. Okay, this is a simple overview about SCADA system. SCADA system is an industrial control system for monitoring and controlling industrial processes. This is a simple overview of SCADA system for water plant. For example, at the top, there's a machine which runs HMI software. HMI software is a component of SCADA system. And also there are more components, such as PLC, RTU devices, and also the actual industrial stuff, such as water pumps and valves. For example, in a SCADA system, HMI application communicates with PLC devices. It sends set points and commands to PLC devices. And PLC devices control and check the flow through the actual industrial stuff, such as water pumps and Okay. So when we say about ICS vulnerabilities, okay, can you give me a few minutes? Oh, sorry for that. Okay, where we were. Okay, so when we say ICS vulnerabilities, as we said, there are too many components of SCADA system. One of them, PLC devices, R2 devices, and also at the other end, HMI softwares. So I call vulnerabilities in PLC devices as hardware, firmware vulnerabilities, and software vulnerabilities are bugs, vulnerabilities in HMI applications. When we find a vulnerability in HMI applications, we will have an opportunity to hack also PLC devices. Because, as we said, HMI applications send set points and commands to PLC devices. This is an example press story about some researchers. As we see, researchers find 2,000 SCADA vulnerabilities in just a few hours' time. So it is really impressive when we read it, but trust me, it's actually really easy to hunt these SCADA vulnerabilities. How and why it is easy to discover SCADA vulnerabilities? As I said, there wasn't a real threat for SCADA systems until 2010. So the SCADA vendors were not aware of the threat also. But after Stuxnet attack, SCADA security got attention. So until these attacks, also vendors didn't aware of secure development, lifecycle, etc. So you can easily find very basic and easy vulnerabilities in these applications. Okay, how to hunt vulnerabilities? If you're a vulnerability researcher or interested in simple reverse engineering, I can say that SCADA applications are just a baby toy for you. It's really easy to hunt. Just analyze the software. This is the main way to hunt vulnerabilities in applications. Just analyze the software and discover potential inputs, input locations, and track and inputs and analyze them. And at the end, you will be able to see security mistakes and programming errors. But of course, this is not the only way. There are too many ways to climb a mountain and path to discover vulnerabilities. Okay, just start with an example, CodeSys SCADA application. CodeSys is a development environment for industrial control systems, and it is used by many manufacturers in the industry. Aaron Portnoy discovered some vulnerabilities in this application. They are patched now, and we will look at how we can rediscover these vulnerabilities. First, we start with the recon step. We try to find potential inputs. For example, this application listens a TCP port. So this is a potential input for us. We can track this input and analyze functions. So what I do for hunting vulnerability in this application? Basically, I just set a breakpoint in debugger for some network socket functions. For example, receive, one of them. Then I just send junk bytes to the application. And after that, I set a breakpoint access to receives parameter arguments, such as buff. And then I will be able to see when application touches my packet in the memory. So this is a hitting point in the debugger when the breakpoint hits our receive buffer. And as we see here, the application compares the first 2 bytes of incoming packets with a special value. It is, as we see in screenshot, it is DD bytes. When we send packet to application, it just gets first 2 bytes and it compares it with special value DD. And if we send DD packet to this application, we will be able to pass this comparison. And then we will come to switch case statements. And these are the key points for looking vulnerabilities. We can find vulnerabilities usually in these places. Each of these statements has a task for doing, operating some commands. Let's look at the switch cases and try to find some bugs, interesting issues. One of the switch cases, case number 13, opcode 13. As we look at the code and string, we can see a string in the screenshot. It's remove file. So we understand that this case is responsible to remove a file in the system. So if we can send a packet for calling this case, we can able to remove a file on the system remotely. So this causes a vulnerability for removing file on the system. Let's look at another case number. This is case 6 in the switch case statements. And as we see another string in this case, put file. And if we continue to analyze this function, we will be able to see that we can upload a file to, by using this case in this application. So actually, this file upload or removing file operations are featured in these applications. But the problem is there is no authentication step before executing these operations. So somebody can reverse the packet structure as we did and use these cases operations for evil. For example, we reversed the packet structure. We understood that it compares just 2 bytes in the incoming packets. Then we can call the opcodes that we found, such as remove file or upload file, and we can use them for evil. To solve kind of these bugs, developers should add an authentication step before executing these opcodes. This vulnerability patched in 2013. Another interesting story about one SCADA application, Movicon SCADA application. It is still 0-day. I have discovered this vulnerability, and on 23 November 2013, I published some details about this vulnerability on Pastebin website. Then, a few days later, ICS CERT contacted us for more details. They saw our analysis on the Pastebin, and they asked for some details about this vulnerability. Then we sent the information about the vulnerabilities. After that, I got an email from the ICS CERT again, a few weeks later. Basically, they say, are you sure about your findings? And are you sure that you tested your findings on latest version? They say, because the vendor says we patched these vulnerabilities in older versions. So your vulnerabilities are old. Are you sure? And they sent also an information about the older version vulnerabilities. And when I look the advisory, as you see here, my findings looks exactly same. I believe that. But I am able to exploit these vulnerabilities in this year. They say it's patched in 2011, but I am able to exploit them in 2014. So what is the problem? Before it, let's look at this vulnerability analysis. After a short conversation with CodeBlue board members, we decided to mask and hide some details about this vulnerability because it is still non-patched. But you can understand that it is really similar to CodeC's example. There are some opcode switch cases which are responsible to call some functions. And there isn't any authentication step before calling these cases. So anybody can reverse packet structure again, and then he can call these cases opcodes for evil. For example, one of the cases about remote information disclosure. First of all, what I did again, just look at the application and understood that it listens a TCP port. Then I discovered and analyzed the packet structure. And if we send a custom packet structure for this application, we are able to jump to switch cases, like in the CodeSys example. After that, there is a remote information disclosure issue in one of the switch cases. What is it and how is it? Let's look at one of the cases calls get version API and sends the return value of get version API to the client. So when we call this opcode, this case, it will just call get version X API, and this API gives information about the operating system. So we are able to get information about the system, remote system, remotely. So this is a simple proof of concept code for the exploit, for the vulnerability. Just a few lines code. When we run it, as we can see in the screenshot, it just sends a packet to the specified port in the application, and then it prints the return value of get version X to us. And as you can see, the 6-byte in red cycle, it is 6, and this is the print. This is the return value of DV double word major version of get version X API. If it is equal to 6, we understand that the remote machine is Windows Vista or upper. If it was 5, for example, the return value was 5, we could understand that it is Windows XP or Windows 2003. So this is an example of another vulnerability in SCADA system, and they say that we patched this, but we are able to exploit it in today. So what is the problem? This is really funny. After I compared older version and also newest version, I understand that vendor didn't patch anything actually. Instead of fixing the vulnerabilities, they just changed the values of switch cases in the application. So, for example, in the older version, case 5 was responsible to call this function, get version X function, but in the newer version, case, for example, case 10 is responsible to execute this function. So I think they thought, okay, hackers discovered our opcodes cases, so we must change the value of opcodes in newer version. This is really facepalm for the vendor. Okay, temporary solution, if there is somebody using this application in their company, you can block remote connection to this TCP port, and if you want a better solution, you can contact me in person for vulnerability details. I can give you them for a drink. And another example, CodeSys Web Visual. This is another module of CodeSys application, SCADA application. And actually, it is a web server for visualization of PLC. And it is usually open to internet. So this is really dangerous for customers of this application. I discovered this, I think, 2 years ago. It is patched now. And it is really basic and easy vulnerability. And I know this kind of vulnerabilities we discovered in 1990s. So it's very interesting. Just sending a HTTP request, a long HTTP request, such as GET or POST, is enough to trigger the vulnerability. And vulnerability is buffer overflow. And the main cause is the application prints all requested data to the user, and it uses VSPrintf unsafe function in the application. So it causes the buffer overflow. Just sending a long bytes HTTP request is enough to trigger this vulnerability. And next slide, we will see that too many systems using this application are open to internet also. And another vulnerability is Schneider vendor. It's a well-known vendor in this industry. I got these images from the company website, and these are the customers who use this application. One of them, an airport in Asian country, and traffic control center in Europe city, and also a gas distribution center in European country. And these are the big references, but this is the very easy and short exploit code for causing denial of service in this application. Just sending a few bytes is enough to trigger null pointer vulnerability and cause denial of service and crash these servers. And it's also patched in last years. And another vulnerability, again, our target is Schneider Electric. The application is Accutech, and the vulnerability is same with CodeSys web server. The application has a web server, and it is enough to send a long HTTP request for triggering the vulnerability. And the vulnerability is, again, buffer overflow. This is a simple analysis. As you see, when we send HTTP request, it uses STL copy for memory copy operation, and it causes buffer overflow. Polling the operator, and this is another vulnerability that I discovered just by fuzzing ActiveX components of the application. The target was Invensys vendor, and I killed 5 birds with 1 stone in this case, because I just found a vulnerability in one application of Invensys, but the other applications of Invensys were vulnerable to the same vulnerability actually. As I said, it's the ActiveX vulnerability. In nowadays, ActiveX vulnerabilities are not important, but if we consider SCADA systems, most of them run on Windows XP or even Windows 98. So it is really easy to exploit ActiveX vulnerabilities and infect SCADA systems. So we have to send an exploit URL to HMI operator, and if we click, we will own. Another vulnerability about IndieSoft HMI software, SCADA software, and I think this company also acquired by Schneider Electric nowadays. And this is a ZDI advisory about the vulnerability. It's remote operation code execution vulnerability, and you can guess it is same with Progea, Movicon vulnerability, and CodeSys vulnerabilities. It allows to attackers execute operation codes without any authentication. Same with CodeSys and Movicon vulnerabilities. But this is really creepy. This application doesn't check even any value for incoming packets. For example, this application doesn't have any custom structure for communication also. So it is just enough to send 1 byte to the application and jump to switch case statements. And this is an exploit code for the vulnerability, as we see. Some of the opcodes is responsible to remove a file on the system. And another interesting opcode, 31, it's able to load a DLL on the operating system. So also there is an opcode which is responsible to send file. So we can use this exploit to send a file, and we can send a DLL file, and also we can use another opcode to run our malicious DLL file on the system. What about finding targets? Most of SCADA vendors and companies also say that our systems are not open to internet. This is not really true, because after a quick search, we can see that there are too many SCADA systems open to internet. I just used Shodan search engine for this example. Here is the result about our CodeSys vulnerability. 3S web server is the banner information of CodeSys web server. And when we search it in Shodan, we are able to see that there are 151 web servers open to internet and use this application. So these are potential targets for our vulnerability. Okay, I will try to show a demo of these vulnerabilities. I hope I can show. This is an exploit code for uploading file to remote machine which is running our vulnerable application. For example, we will upload a CodeSys TXT file to the remote system. These are the system. Okay, we are in the directory of SCADA system, and this is our vulnerable application, CodeSys gateway server. Oops. Okay, we will just upload a file by using this vulnerability, exploiting this vulnerability. If it's success, it will upload a TXT file, name it CodeSys, CodeBlue. Let's try. And as we can see here, we are able to upload any file to the remote machine by using this vulnerability. And also, as we talked, we have another vulnerability which is giving opportunity to remove a file on the system. So we will try to remove the file on the system. Let's run other exploit. Oops. Okay. And when we run it, also, as we can see, we successfully removed CodeBlue file on the remote system. And also, let me show the zero-day vulnerability, which causes remote information disclosure security issue. It was for Movicon application. So when we run it, as we see, it gives a result of get version X API, and this 4 bytes 0005 is a return value of get version X, and 5 value says that this is a Windows operating system, which is Windows XP or Windows 2003. If it was Windows Vista or upper, such as Windows 7, this value will be 0006. Okay. So, conclusion, critical infrastructures are juicy targets for both of hackers and governments or security researchers. As a security researcher, as we see on press stories and news, it gives a fame to the researcher or profit and money for the researcher. And also, we see that hacktivists are started to hack SCADA systems. They are trying to find SCADA systems which are open to internet and targeting them. And as we see in the examples, these applications are really buggy applications and insecure because they were not aware of secure development, I think. So you can easily discover vulnerabilities by just simple reverse engineering or fuzzing tricks in these applications. Okay, thank you for listening to me. Is there any question?
Thank you for your presentation.
You mentioned hacktivists are targeting SCADA system too. So is there any news on that?
Yes, I saw some news about it, but I don't have an example for it, but hacktivist groups such as Anonymous and some radical Islamist hacktivist groups started to expose these SCADA systems which are open to internet, and also they published some default passwords for SCADA systems on several websites. But I don't have any example for now.
Okay, thank you.
Any other question? Okay. I am here around if you... There, okay.
いくつかの脆弱性を発見されたとのことですけれども、そのうちファジングで発見できたっていうのはどれぐらいの割合でしょうか。
One of them I found by fuzzing. It was an Accutech case. Other vulnerabilities, as you see in the slides, were logical vulnerabilities, not was a memory corruption or buffer overflow, such as uploading file, removing file. These are logical bugs in the application, so it is not easy to find them via fuzzing. But I didn't use fuzzing method, but it is really useful for SCADA applications. So you can discover vulnerabilities by fuzzing very easily in these applications.
ありがとうございます。
Thank you.
Thank you.
Okay.
Hi. As you have mentioned, the SCADA system is actually mainly for controls of internal systems. Why are they, according to your experience, why are they even connected to the internet or network at all?
Okay. In last years, the vendors developed some features like visualization to open SCADA systems. How can I explain? They just open the internet for visualization, so they are able to give a feature like controlling it over internet remotely. So this is why some SCADA applications are open to internet. Any other question?
In the answer to the first question, you said you have some news on that hacktivist is showing the vulnerability and exploit way on the internet. And do you think the hacktivists can do actual attack, or just they are showing the vulnerability and exploit?
Can you repeat your last sentence?
Or they can just showing, or do you think they are just showing, or they are attacking in actual?
I see. I think they are just showing the vulnerabilities. I didn't heard any case that hacktivists really hacked or compromised a SCADA system or power plant. You know, these operations requires more work. As we look at Stuxnet case or Dukuk case, it needs more solid work to do this kind of attacks. But as we guess, hacktivists or protesters are just teenagers which are staying at home and trying to protest some things. So it is enough for them to deface a website or showing some default passwords of SCADA applications. But I don't think that they are really targeting SCADA power plants, etc.
And thank you. And just asking your personal opinion, does such a hacktivist work is good for society or not? How do you think?
Can you repeat again?
Yeah. Is such hacktivist work is good for society or not? How do you think? I'm asking your personal opinion, not your official statement.
I think it's good. It also helps to improve.
Yeah, I totally agree. Thank you.
Thank you. Any other idea, question? No? Okay. ありがとうございました. And I am here. Okay.